Hi everyone, very good evening. I hope I'm audible. Kindly confirm in the chat if I'm audible to all.
Yes, you are audible.
Thank you for confirmation. Very good evening and welcome you all to the session. I hope I'm audible. Let me just get the things clear a little bit here. Very good to go. Very good evening and welcome again to the session today. Today it's a webinar on generative AI. So in this 1 hour short capsule, we're gonna go ahead and explore what is generative AI, what do we do in that, and the kind of applications that we develop. We'll also talk about what is prompt engineering and what could be a set of best practices to perform prompt engineering as well. So, well, it's going to be a lot more bundle of exciting components about generative AI. So, if you are somebody who is looking to explore what is generative AI actually, what do we do in that, this webinar is for you. Let's start it. To start with, first of all, who am I? My name is Anshu Pandey. I work as an AI and data consultant. As part of my role, I have worked as I sort of help my customers in developing analytics and AI solutions, generative AI solutions as well. I help them in architecting projects to developing technical architectures, performing feasibility around analytics and AI solutions. Besides that, I'm also Microsoft certified trainer and as well a wireless certified trainer, and spent almost last 15 years in the space of telecom, finance, education industry, working with different organizations. With that, let's get started. The first thing to talk about before we get to generative AI, the other segment of generative AI, which is AI, what it is. Well, for sure, today at this moment, out of all joining this webinar, I'm sure that everyone would have heard of what is AI and should be having some sort of knowledge about, or maybe uh, uh, logical definition of what AI is or what it could be in your mind. So it's not something that we're talking about, something which is very new, very unknown, right, to the real world and very unheard of, right? While delivering similar webinars, if I have to say 10 years back, I used to get some audience who wouldn't know what is AI, but today it's very common thing. Yep, as you would already know, what is AI? It's a way to make machines imitate as intelligent as humans, a way to make machines think or act like humans, right? For example, the way we humans can drive car, a machine driving car, like self-driving car, can be thought of as an AI solution or a example of AI application. The way we humans can speak in multiple languages, right? I'm sure all of you could speak in potentially 2 or 3 languages, right? A machine doing that, such as maybe a computer application like Google Translate, is an example of AI. Similarly, the way we can solve problems, maybe we have a knowledge about specific area and we can answer questions. A chatbot can doing the same thing as AI solution. The way we can recognize our friends and family members, face recognition agent doing the same job, right? Recognizing people based on their facial pattern is an AI solution. If you have a question, what is not AI? Well, the answer would be something which is quite rule based, very explicit in nature, is not AI, right? So the way we have been programming the traditional software, right, or maybe more of a traditional approach of how we have been programming software is been more like if do this, else do this. So it's been quite a lot of explicit programming, right? So in general, in software engineering, we make use of explicit approach to develop applications, develop logic that is not AI. So this is not AI at all. What is AI on the other hand? If you don't write explicit program, rather you write implicit equations, right? For example, uh, ax1 plus bx2 equals y. Now, the exact relationship between x1, x2, and y is not known because a and b is not known. It's not defined by us. Just we define that maybe x1, x2, and y can have some relationship. And let's say if you feed some data to this equation and you get an optimized equation designed by the model itself or designed by a computer program, right? Which is where it itself identifies or determines the most optimum relation between x1 and x2 and y. That's AI, right? Where we humans don't define the rules. We humans don't define the rules in a very explicit manner. Rather, we let the computer program, extract, optimize its own set of rules. That's AI. So face recognition system to language translation, speech recognition, speech generation, everything is AI. That's about what is AI. Well, today this space is growing
Space
more
is
than
growing.
any,
Space is
much faster than ever, I would say. And the growth in AI has picked up. So, well, I was summarizing where we talk about what is AI from an engineer perspective, right? So, let's say if we say, uh, as an engineer, how should I look at it? What is AI? So, a way to look at it could be as an engineer, as a developer. For me, AI is uh, a collection of tools, a collection of algorithms where we have a set of algorithms and potentially we can pick one to develop a solution for a specific use case. So let's say I have collection of use cases such as you want to develop a forecasting solution. So out of 5 or 10 available algorithm, let me pick LSTM as a technique to develop forecasting solution. Or else if it is about image recognition solution, let's pick CNN to develop that. So likewise, you can think of AI as a collection of algorithms, so many algorithms. And you can pick, depending on the knowledge that you have about the algorithm, one of them to develop a solution out of it. AI is not very new. It started back in 1950s, and it's there into existence from quite a long. Uh, but yeah, the lot of research or the work that we use now or leverage now for applications has happened in last 20-30 years mostly, right? In fact, machine learning is not very new, right? It's there into existence from 1990s, 1990s, almost 2000s, right? And since 2006 or 8, when the digitalization wave picked up, the applicability of machine learning started becoming more feasible. And since 2015, since the democratization across ML and AI space started happening across the globe, uh, AI started gaining a lot more visibility, implementation, as well as uh, use cases, adoption. 2014-15 was the time when deep learning started flourishing quite a lot and started becoming backbone of deep learning algorithms, started becoming backbone of almost every ML use case. Now, if you talk about till here, the kind of differences within this. So AI can be thought of as a broad collection of algorithms. Now, within that, there are certain algorithms that learn from data, right? So you can say that here we talk about algorithms which learn from data. And these algorithms are sort of referred as ML algorithms or machine learning algorithms. And then we have another bucket within that where we talk about algorithms which can perform automated feature engineering. We talk about algorithms which can perform automated feature engineering. So those fall under deep learning. So AI is a broader collection. You can think of a big umbrella under which we have a smaller umbrella that is machine learning, where we have algorithms which specifically learn from data. And then we have algorithms which can do automated feature engineering. That means the algorithms can itself
Hi, am I
identify
audible,
which
sir?
data is to use to learn from. And that is
Hello?
deep learning space. Yeah, there is a question looks like. Okay. All right. Well, if the question is what is algorithm, the answer is you can think of it as a set of steps. An algorithm is a process. It just the process is here explicitly defined. For example, let's say if the question is how to drive a car, is a process, right? You start with gear one, and then accordingly, whenever you find there is some sort of traffic, you go down gear, and then if there's no traffic, if there's open road, you want to increase the gear size, all of that, right? So that's an algorithm, and in automated cars, those are kind of programmed. So that's an algorithm, right? And when it comes to algorithm and machine learning, it's just those algorithms are programmed using mathematical steps or designed using mathematical equations, right? So that's a difference, or that's a full idea about what is algorithm. All of these algorithms are heavily backed by mathematics, right? Specifically statistics and algebra. And yeah, if you have fair interest in mathematics, this is something that you should definitely explore. Coming up, furthermore, 2017-18 was a timeline when deep learning started gaining a lot more visibility, and researchers kind of put on a lot of effort in improving deep learning solutions, algorithms, and applications. And that's where 2017-18 was a time when generative AI started emerging. It started primarily with GANs, generative adversarial networks, where the neural networks were programmed to generate images instead of consuming images. Furthermore, from transformer approach, which is primarily designed, to improve the Google search
Hi, am I
engines.
audible, sir?
Yes, you are.
You need to reshare your screen. Participants are unable to check that.
Is the screen not visible?
No, sir.
Strange. Let me do that again. Let me know if that's visible now. I'm gonna just change some of the slides to see that if it kind of goes up.
Visible now. Thank you.
Well, yeah. So we were talking about machine learning, specifically deep learning, and so AI, machine learning, and deep learning are the three broader buckets. And 2017-18 was the timeline when generative AI started picking up, and it started gaining a lot more visibility as well. Gains definitely brought a lot more attention in the market across different people, I mean, different segments, but then transformers were the key disruptors. 2018, when GPT was launched and GPT 1.0 by OpenAI, same year BERT, and then subsequently multiple language models. And then we go November 30, 2022, the date on which ChatGPT was launched. And then that was more like a birth of the generative AI era, right? The whole disruption, right, attention was brought because of that single tool. ChatGPT brought generative AI in almost every hand. So we all, as a end user, started experiencing what generative AI is. So in a nutshell, coming back to engineering point of view, uh, generative AI is a space of AI where we talk about generating content instead of consuming content, right? For example, in all the applications that we develop across AI, machine learning, deep learning, we intend to develop models which can consume content to generate or to provide prediction as the outcome. Whereas generative AI models do the just opposite, right? They consume the prompt and generate content out of it. And yeah, so from deep learning algorithms, generative AI algorithms started doing. So if you look at from the algorithm point of view, right, you can think of generative AI algorithms are a subset of deep learning algorithms. So if there are 100 algorithms in deep learning, you can say 20 or 10 of them are part of generative AI. And from the logical application point of view, AI has two broader buckets: discriminative AI and generative AI. Right? That's another way to look at it. And yeah, generative AI is where we talk about developing models which can use to create new content, which could be text content, which could be images, videos, all of that. So that's about Gen AI, what it is, right? And let's talk more about it. Let's go further into this. So an example of discriminative AI can be, let's say, you develop a simple prediction solution where we have a model which can be used to predict the price of diamond, right? So let's say we have entered the value input is 1.23 carat and 3 and color 6 likewise and clarity, and then see what's the prediction. So the prediction is price of diamond, right? That turns out to have some sort of value which is 17264, right? That's the prediction that we get. So that's generative AI. Sorry, that's discriminative AI, right? It's about you train a model not to generate content, rather to discriminate between what inputs are fed to it. For example, when the value of carat is lower or higher versus color is lower or higher, or the clarity is from the scale of 1 to 8, how does the price differentiate, right? Is it going to go higher or lower? So the model is able to learn that based on the given values, set of values A and set of values B, how the pricing goes up or down, right? It's able to discriminate between the feature values to predict the label or target. That's where we call it as on a broader level, discriminatory AI, where AI is designed to work in a way that it sort of discriminative AI. You can think of it sort of is designed to make it work in a way that it sort of accepts content and predicts intent, right? That's the nutshell idea of what it does. So discriminative AI models always accept content, which could be text, images, audio, video, numbers as input, and they generate intent, which could be prediction, summary, type of email, sentiment as output. On the other hand, generative AI is different, right? How is it different? Is it different that we let the model generate content, right? Here you can see that we are kind of able to generate content here, right? So you ask a prompt as input, create an image of two American ladies posing in a professional dress for an advertisement, and then the model generates an image for that, right? So here we uh, train models or talk about the models which can actually generate realistic content. If I have to give you some demonstrations around it, maybe you can give a try after this webinar to navigate to Google and search for Hugging Face. And that's one of the very popular open source community platform for AI and machine learning. And you can explore multiple models over here. So let's say if I go to models here, you would see that there are multiple options of different types of model. Let's say if I go to object detection. So object detection is a use case or application which falls under discriminative AI, where we train the model to discriminate between the objects. For example, if I go for the first model, YOLO V9, this model is looks like it's quite recently launched. It's quite new as well, YOLO V9, and it's designed to discriminate between the objects. Right. Let's go for another one, which could be Facebook DETR ResNet 50. So this is another model. Now let's say if I upload an image here, I'm going to go ahead and upload an image, which could be, let's say this one. Now this model is designed for object detection. As you can see, it says the task is object detection. And whenever I upload a new image, it's been able to discriminate between the content within the image, the background, and the objects, which is three ladies, and it's able to identify person, person, and person. So this is example of discriminative AI, where you feed image as input and the model simply says that where person is person, person, person. On the other hand, example of generative AI could be on the same platform. Let's say if you go for uh, GPT-2. Let's say I liked generative AI course by Collabora, digital, something of that way, and compute, right? So it's going to kind of go ahead and generate more text out of it. As you could see that it has tried out completing that text. If I further say go ahead, it's kind of going to go ahead and further complete the text in multiple sequences. So if I say I like generative AI course by Collabora Digital Solutions Group for PhD focused on nature of abstract and graphs, that's one of, again, GPT-2 was not as accurate as you would see for GPT 3.5 and 4. It does that job. This is an example of generative AI where you feed something as input and then model tries to build on top of it and generate further content out of it. So that's a key difference. Let's summarize. What's difference in discriminative versus generative? In a nutshell, discriminative AI is where you develop the models to learn to discriminate between inputs and only generate intent as output. Often discriminative AI solutions are not so complex and difficult to develop. Compared to that, generative AI is about developing a model which can generate content. And generative AI models are built from deep learning, which are more complex and require more data, more computational cost. Gen AI models are more expensive to train compared to discriminative AI models. On the other hand, as all generative AI models come from deep learning space, they are black box. They are not interpretables, whereas discriminative AI solutions are interpretable. This is an example. If you talk about some algorithms in both the buckets, example of discriminative AI algorithms could be simple linear regression or logistic regression to maybe ensemble techniques such as random forest or XGBoost or neural networks for that reason. Whereas Gen AI models algorithms could be GANs or LSTMs or maybe of variation order encoders. That's an example of difference in generative AI versus discriminative AI. Now, once we have done till here, let's move forward further and talk about what's more in generative AI. What are you actually doing generative AI in a nutshell, right? This is an example of history of how generative AI has actually moved on. As I mentioned earlier, 2015 was time when GANs started evolving, right? As generative AI in general started flourishing a lot from 1950s, and then 2006 and 10 was the timeline where it gained a lot of limelight because of digital disruption. And 2015, 2018, as the compute disruption happened, compute started becoming low cost and available at a higher configurational compute started becoming available. It was possible to actually train complex models as well. And that's where CANs, transformers started flourishing a lot. 2018, 2019 was the timeline when generative AI started gaining a lot more visibility. And again, 2020 is where we got to see ChatGPT. So that's a quick short history. And generative AI is from last 1.5 year almost. It's been the buzzword. It's been the poster boy in the technology world, and you can say most research organizations say that in next 2 3 years, the percentage of total technology spent is gonna come a lot from generative AI. And by 2032, this is going to increase to almost 12%. That means almost 12% of total technology spend that any organization does, they'll be doing that specifically because of Gen AI, or maybe that'll be specifically dedicated to Gen AI. And that's the strength you can say, or that's the market size that you can expect. Well, these figures are from Bloomberg, and that's one. Now, some of the key organizations that you should actually know about who have contributed a lot to generative AI. And if you want to build up skills around generative AI, learn more about it, these are the tools and platforms and frameworks that you should actually know about it. OpenAI is the torchbearer in the market, you can say, and the front runner in the overall industry of generative AI, as OpenAI is the organization which has launched ChatGPT. So they are the key disruptors in the Gen AI space, right? OpenAI does not only offer ChatGPT as a solution, they offer multiple solutions. OpenAI has a variety of models to offer to their customers, starting from generative AI models, GPT series, GPT 3.5, GPT-4, GPT-4 Turbo, and variety of models within GPT. They also offer options to fine-tune GPT models as well on your custom data. At the same time, you can also consume these models via API key, via assistant, and few other formats. OpenAI also offers multiple models for embedding generation, for content moderation, text to speech, speech to text, language translation, and few others. In any of the generative AI solutions or skill sets, you definitely need skills on leveraging OpenAI models, understanding to OpenAI models, image generation, text generation, and recently they also launched one of the very interesting product, Sora, which is for video generation. Then comes Hugging Face, a completely open source platform community which has a lot of interesting components to actually explore for. So in case if you're looking for open source models anywhere about machine learning models, let's say a model open sourced by Meta, Google, OpenAI for that reason, you can find every open source ML model, almost every popular open source ML model over Hugging Face, right? So if you are looking for open source solution, Hugging Face is a way to go. Besides that, it also offers multiple frameworks or libraries such as transformers, diffusers, which are widely being used to access a pre-trained LLM, fine-tune a pre-trained LLM, retrain a pre-trained LLM, access embedding model, fine-tune embedding model, access LLM from different platforms, diffusers to access diffusion models for image generation, audio generation, or video generation as well, or animation generation for that reason. Hugging Face and OpenAI are two most critical components or platforms that you should actually have knowledge of. The other is Stability AI, another flagship organization which has dedicated, which is dedicated multiple models in the space of image and text generation, such as Stable LM, Stable Diffusion. Uh, these are multiple models by Stability AI. And last is LangChain. LangChain is the most popular framework today to develop generative AI solutions. So what if tomorrow I have to attach GPT 3.5 to my database? How do I do that? Do that with LangChain, much easier. What if tomorrow, if I have to make OpenAI get access to a collection of PDF files that I have about my annual reports and give me answers from those annual reports? LangChain is a way to go for that. What if I have to develop a custom embedding solution, a RAG solution for that reason, agent based on LLM or a chain based on LLM? LangChain is the way to go for that, right? The most popular framework for application development using large language models. LangChain is the way to go. So these are some of the key organizations and platforms and skills that you should actually be aware of, and you should be knowing if you are entered into the generative AI space. All right, that's one. Furthermore, Now we're going to go ahead and explore what are the key tasks that we do in generative AI. So what do we actually do in generative AI and which problems do we solve? For example, if you already come from discriminative AI space, you would know already that, or maybe in general, if you come from AI space, you would already know that the problems that we solve include classification, regression, clustering. The question is, what do we do actually in generative AI? So one of the tasks that you do is text generation, right? As simple as writing prompt and expecting ChatGPT to generate text, right? So you can simply say, explain the principal theories behind maybe, let's say, or write a poem about generative AI, it can do that. Here's an example of principal theories and values approach in management that I evolved in last few years. So ChatGPT can write answers for that. Uh, Text generation, a very popular platform is definitely ChatGPT. Models include GPT 3.54, Gemini or Bard or PLM by Google, Llama by Meta, Stable LM by Stability AI, Cohere as well. These are a variety of models which are available and can be used to do text generation. The other is image generation. We expect a model to generate images based on given prompt. So let's say based on the given prompt here, the model is able to generate realistic new images which don't exist at all ever anywhere, right? So these are images generated from text, right? And multiple models are available. One of them is definitely DALL-E 3, right? That is by OpenAI. If you consume these models, one of the way to do that is you can also use Copilot, Microsoft Copilot. So let's say if I go ahead and say, write a poem on generative AI. So the model is going to go ahead and write poem around that. This is an example of GPT writing poem for us. A very novel, non-written, completely copyrighted poem, right? This never exists on internet. And this is completely my product or your product for that reason, you can say. Similarly, example of image generation could be create an image of a US village back from 1915 where there are people walking on street, two youngsters laughing and playing cricket, something of that sort. Make it realistic, use simple colors. Here we go. This is an example of writing prompt as input and expecting model to generate image out of it. And this is going to happen with the help of DALL-E 3, and we can expect the model to generate certain set of images as well. Here we go. And these are the set of images that we got to see from the model, right? Again, these are completely new and allows you to make modifications as well if needed. So let's say I want to kind of modify certain component of it. So maybe this one. And rest color pop. There we go. So a completely new image, right? That's image generation. So image generation models are there. DALL-E 3 is by OpenAI. Stable Diffusion, a completely open source model for image generation. You can use that as well. Midjourney by Discord, the flagship model and the most popular model for image generation. StyleGAN 3 by NVIDIA, VA2 by DeepMind, BigCan by DeepMind, right? These are a variety of models, and there are many more for image generation as well. Furthermore, audio generation is where text to speech. So audio generation is not very new today, and there have been multiple models that exist already. Uh, but yeah, recently Google's model and Microsoft's models have shown a very good results in quality of audio generation. Jukebox has been a project by OpenAI where it can be used to generate songs almost as realistic as any real singer would sing that. So you can expect a model to generate a song as real as the one sung by Eminem or maybe Rihanna for that reason. And Yeah, so AveNet, Jukebox, Tractron, Synth, these are a variety of models in audio generation space. Furthermore, video generation, right? Recent launch, Sora, the flagship model, amazing model. You can see here is an output by Sora. Given a prompt, a stylish woman walks down a Tokyo street filled with warm and glowing neon and animated city signage. And she wears a black leather jacket, a long red dress, and black boots, and carries a black purse. She wears sunglasses and red lipsticks. She walks confidently and casually. And the model generates this video. This is not a real captured video, rather artificial synthetic video generated by a diffusion model. So some of the recent platform is definitely Sora, Co-op Video, Make a Video, VA for Videos, Defined. These are variety of models available. This space is still progressing a lot, and it's gonna get to see a lot of disruptions in next 4 or 5 years down the line. The another important space where I am sure you would be interested into is code generation, where you can actually expect the model to generate code for you. OpenAI Codex has been one of the very popular model, and now that's part of the backend of GitHub Copilot. And so if you haven't used GitHub Copilot yet, I would strongly recommend you to do that. And that's amazing model. I would strongly suggest you to try out using GitHub Copilot as well. So yeah, Copilot can help you generate code and write code, maybe perform debugging, perform code management, code documentation, code optimization, all of that. You can use platforms such as GitHub Copilot, Tab9 Kite, Codium, Code T5, AWS Whisperer actually, and a few more. That's about code generation. So these are a variety of tasks that we actually do in generative AI space. And so 5 of them we've covered so far: text generation, image generation, audio generation, video generation, and code generation. These are the 5 broader tasks that we do in generative AI. At the end, backbone, what's the technology behind this, right? So the key technology behind this is large language models. I mean, image generation and video generation doesn't happen with LLM. There is a diffusion model. That's a backend technology. But definitely when it comes to code generation, text generation, LLMs are the way to go. And so what are LLMs, or what are large language models? Large language models, think of it as a model trained with a huge amount of data, which makes the model understand the human language as good as we humans do, and generate or convert human language or text into vectors, generate another vectors, and convert vectors back to text. That's what LLMs do. Language models which have up to 100 million parameters are referred as small language models. More than 100 million large language models. The recent models like GPT series models are also having parameters up to 150 billion or even more than that. The property of LLMs to be able to interpret human language as effectively as human has made it possible to be used across a variety of diverse applications and tasks, such as language translation, text summarization, text generation, writing codes, writing conversation, performing conversational flow as well, all of that. LLMs work in a very simple manner. People who develop LLMs, they use a lot of unlabeled text. For example, GPT was trained on almost whole data available on internet. And the trained model, the backend algorithm or technique is transformer, which is a self-attention based approach. These models are trained in self-supervised approach. That means we don't label the data manually. Rather, we let the process of training, that is training process, do the labeling and generate labeled data. And finally, we get the trained language model. This language model can then be used to generate content. Some of the popular language models include BERT, GPT, BART, T5, Stable LM. And language models are widely being used today across text generation engines. ChatGPT is the flagship application. Code generation, automation tasks as well. Variety of automation tasks are being achieved on the top of large language models. That was about the content for the day and the coverage. Right now, we'll dedicate the last 15 minutes almost to questions and talk about some of the concerns and questions and queries that you got about generative AI. So you can always go ahead and put your questions in the chat, and I'm happy to answer that. Yes, you can always put your questions in the chat, and I'll be happy answering those questions. Any queries that you got about what is generative AI versus anything that you got concerned about. And meanwhile, yes, definitely, the set of tools to explore is one, prompt engineering, and you should explore how to use generative AI models more effectively. Specifically, let's say how to write better prompts with ChatGPT or Copilot for that reason. And because that's going to become a skill, and that's going to be a new addition to skill for almost everyone. For example, the way understanding of Microsoft Word or how to use Microsoft PowerPoint, how to write email is an essential skill today. Prompt engine is going to add to that list as an essential skill set. So there are certain questions that I'm going to take one by one. First is impact of generative AI and coding jobs. So coding jobs are going to become much more interesting and much more optimized. So coding jobs used to be a little bit boring and a little bit troublesome and complex. Now those are going to become more easier. So coding jobs are not going to go away. It's just the kind of applications and software that we've been programming so far are going to optimize. So a lot of low level code, a lot of manual code. We don't have to write manually every time. But yeah, a Copilot can help us, assist us doing that. Coding jobs are not going to go away. Definitely, there will be slight reduction in that, but that would, on a whole, add out to shift, not reduction, at a calculated count level. So if you look at the count of coding jobs, for example, if they have 10 million, it's going to always increase more than 10 million. But the type of coding jobs that used to exist, that won't exist anymore in your future. So if I have to summarize again my answer, two things. One, quantity will increase, but there'll be a shift in terms of what type of coding jobs used to exist versus what will exist tomorrow. The other question, labeled data versus unlabeled data. Well, Gen AI models are by default trained on unlabeled data. They're trained in self-supervised manner. That means the algorithm or the process itself generates labeled data from unlabeled data. For example, uh, let's say if there's an article, uh, the boy is playing cricket in the school, so the model is going to generate boy is input, plays output, plays input, cricket is output. Likewise, it's going to generate x and y from the given statement. That's what we call it as more of self-supervised manner. So LLMs are trained in unsupervised way. LLMs can be used to perform a lot of supervised tasks, right? That is tasks which are actually done on labeled data. I hope that answers the question, Vinayak. If not, kindly put a clarified one in the chat box. There's another question. How do you compute the costing for using these models? What are tokens? Very interesting question. Well, tokens are, you can think of tokens as collection of maybe split of words. For example, the concept of tokens actually was brought initially by Google and then Facebook, much more broader way. The reason they brought it is because when you search on Google, it kind of, you get better results easily because you don't make spelling mistakes while writing search on Google. But when we type anything on Facebook, we don't care about spelling mistakes. Sometimes we write hi as HIIIII, multiple I's. So what are tokens? For example, if you sometimes write completing, right? So completing is like, it's going to split into three tokens. Let's say COMP, LET, ING, right? So ING is one token, COMP is one other token, LET is another token. So a token is like a root component of a word. At times it can happen one token is one word, sometimes one token, one word is two tokens or three tokens as well. And yes, the costing is happening, costing happens based on token. How many tokens are processed by the model, because that adds to computational cost, right? Each model has a limited number of tokens that it can process and then cost per token as well, right? So that's the costing structure. Uh, the open source models do not have that specific set of cost available, but then the paid models available by OpenAI are always having a specific cost. The cost is going to decrease over a period of time as soon as the users increase, but then you'll always have a cost with paid proprietary models available. That's another question. Where to start the journey? Well, the journey is to understand what applications to develop, how to use, become a citizen developer yourself first. For example, learn prompt engineering and become good at using generative AI models at first, and then think of getting into the space of developing solutions out of it. Also, parallelly explore how exactly can it get integrated to your current job to explore it further. What exactly is the role of RAG in generative AI? Very interesting question. So see, generative AI or LLM lag with three critical challenges. So first one is uh, a large language model may not have knowledge about your internal data. For example, let's say if I work in finance, now LLM may not know if I'm working for a company ABC, what strategies, investment strategies my company ABC uses to make investments, or maybe it may not know annual reports of every company more thoroughly. So they lack knowledge of private data. Second, they lack knowledge of recent data. If something has happened just a week before, LLM would not know about that. Third, they can get hallucinated. Sometimes if you call them that, well, tell me about investment strategy that possibly uh, uh, I should use for National Stock Exchange in India or maybe Nasdaq in US. Likewise, it may not know about that, so it may get hallucinated and give you a very generalized strategy around it. To handle these three challenges, we go for RAG. RAG is where we make the LLM access our knowledge base in the form of vector databases and get more contextual relevant knowledge from the existing database to answer the questions out of it. So that's the structure of RAG. So almost all the enterprise applications are going to shift to adopting generative AI via RAG. RAG is a pathway for them to access or to leverage LLMs. And that's how it is happening now, right? So RAG is one of the hottest skill set. If you talk about hard skill today, or as a developer, a skill set that I should be having to develop any Gen AI solution, or if I have to become a generative AI engineer tomorrow, what should I know? RAG is the way to go. You should know RAG, how to develop RAG solutions. That's the hottest skill set today. Hard skill, how to say. Generating large data sets for training models could become a challenge, right? And also, will it become more specialized? What do you think? See, large data set would not be a need anymore, actually, right? Because again, synthetic data is definitely going to be a need, but it won't be a much more need as it was before Gen AI era. So there's going to be a shift in terms of how do we train versus customize versus fine tune and use transfer learning in practice. So there's going to be amazing shift in next 3 years across how enterprises manage machine learning models. One interesting shift is going to be instead of managing 10 different models for 10 different jobs, the enterprise is going to shift to managing 10 different prompts. For example, having a single LLM writing a prompt A, I can do sentiment prediction, sentiment analysis, I can do emotion extraction, topic modeling, variety of tasks. So to reduce the burden of ML ops, instead of having 10 different models for different tasks, we will use 10 different prompts. Prompts are easy to maintain, easy to modify, easy to create as well. So that's going to be a shift. We will no more be developing specialized NLP models. That's one shift that you would see, right? And models will be replaced by prompts in practice. So there's going to be prompt ops, you can say in future, right? That's you can expect. Second, LLMs for the prediction tasks also are going to become much more tailored. So you can expect LLMs which can process structured tabular data effectively in future. In next 2 to 3 years, a lot of embedding models are going to come up which can process your tabular data and generate vectors out of it, which will be a backbone to develop all the prediction solutions in a different approach. So these are the shifts that you should expect in next 2 to 3 years. How do LLMs scale on production? Well, LLM ops is one of the very emerging and I would say growing field. And we are not at the level where we talk about stability. So it would be very not precise to answer this question at the moment, right? Because I won't be able to answer the best skill because that doesn't exist, or best approach that doesn't exist yet. This space is still flourishing, right? But yeah, and the reason it is flourishing because it's actually a challenge. So you have hit the right note, I would say, right? LLM scalability in production is a challenge, and there are multiple ways to manage that, right? Definitely, distributed computing is one. Distributed data storage is another. Moderation, monitoring are a few of the other components, and there are frameworks and tools being developed. For example, Langsmith is quite a popular framework now to manage and monitor debug LLMs in production. Uh, Restricting them from not hallucinating. There are three ways to do that: effective prompt engineering. Second, fine tuning LLM. Third, third is RAG. So RAG is the best way to stop LLMs from getting hallucinated, right? So these are few ways. How to choose between pre-trained models versus writing own new model? Well, we always want best option to choose is to use pre-trained models. Uh, Only in cases where you have very custom domain specific use case, go for your model. Otherwise, use pre-trained models. Gen AI can't predict anything based on historical data. It can actually, right? It cannot do very effectively at the moment. But then, as I mentioned, as you will have models which can generate vector data from tabular data, you would see that. I realize that Gen AI sometimes generate biased results. How can I handle biased results from Gen AI? Well, as I mentioned, that is hallucination, effective prompt engineering, fine-tuning LLMs, and RAG is a way to go for that. Great. It looks like I have been able to complete the list of questions, right? Amazing. I really love the set of questions that you ask, and it shows that you have been exploring the space quite actively. And I would really wish all the very best to all of you to explore this space even more thoroughly. And we would love to hear your thoughts, your questions, and queries at Cognitia and Collabra Digital team. And uh, get to talk about more of the application that you're working with and developing. And if you need any help, we would be happy to do that. Thank you for joining this webinar. I hope you enjoyed this. Hope to see you further in upcoming webinars by Collabra Digital and Cognitia.
Thank you, sir.
Thank you.